Okay, let's dive right into this. We're interacting with incredibly smart AI systems every single day now, right? They're writing complex code, drafting up legal documents, even helping to diagnose medical conditions. But if you've used them enough, you've almost certainly bumped into a truly baffling phenomenon. Have you ever noticed how an AI can confidently, enthusiastically, and just so articulately give you the absolute wrong answer? I mean, it doesn't stutter, it doesn't hesitate, it just presents total fiction as undeniable fact. Like, remember when a lawyer famously used ChatGPT for case law, and the AI just confidently invented entirely non-existent court cases, complete with fake citations? Yeah, it's fascinating, but it's also a little bit terrifying. So, welcome to this explainer. Today, we're going on a deep dive to investigate exactly why artificial intelligence suffers from this massive blind spot, and we'll look at the cutting-edge science that's desperately trying to fix it. So, this brings us to the central mystery we need to unpack today. Does AI actually know when it's wrong? It sounds like a simple question, but it has some really profound implications. What we're doing here is essentially a quest to uncover a missing psychological component in artificial intelligence. You see, an AI has terabytes of data, it has these advanced neural networks, and just massive computing power. But does it have the capacity for self-doubt? Think about it. When a human answers a question, we usually have a gut feeling about whether we're totally guessing or if we actually know the facts for sure. We feel our own uncertainty. Does an AI have that internal warning system, or is it literally just blindly predicting the next word over and over?
To answer that, we have to look at a really crucial observation from recent research. The consensus is pretty clear. Hallucinations by large language models can often be characterized by specific metacognitive failure modes, and a huge one is overconfidence. This perfectly describes the phenomenon of high-certainty hallucinations, and it's absolutely crucial to understand this point. AI frequently makes mistakes, not because it lacks the necessary data in its training set, but because it fundamentally lacks human-like self-doubt. It isn't failing because it's ignorant, it's failing because it is overly confident in its ignorance. It just lacks the ability to hit the brakes and say, wait a minute, I might be wrong about this.
Which leads us directly to the star of our show today. We need to formally define exactly what it is that the AI is missing. The scientific term is metacognition. Now, formally, this is defined as the ability to monitor, assess, and regulate one's own cognitive processes. But in plain English, it's just thinking about thinking. Now, I want to be super clear here to keep things grounded, because it's easy to get carried away. We are not discussing some sentient, feeling robot that wakes up and ponders its own existence in the universe. No. We're talking about a functional, artificial self-monitoring system. It is strictly an engineering mechanism that allows a system to evaluate its own computational state.
To really grasp how this works, let's break metacognition down into its two interacting halves. You've got monitoring on one side and control on the other. Think of it like a student taking a really tough final exam. You look at a difficult math question, and suddenly you get that sinking feeling of dread where you realize, I have absolutely no idea how to solve this. That realization right there, assessing your own uncertainty and your task performance, that is the monitoring phase. Then, a moment of resolution hits you. You decide, okay, I'm going to skip this question for now and maybe ask the teacher for a hint later. That decision, planning, selecting a strategy, and reallocating your effort, that is the control phase. We humans do this looping process constantly without even trying. AI, traditionally, does not do this at all.
And this brilliantly illustrates exactly how scientists are trying to map that human process onto machines. This massive taxonomy of current research is basically the blueprint for the future of AI, and it proves that teaching AI self-awareness is an exploding field of science right now. I really want us to take our time and understand the structure here, because it maps out everything we're going to talk about. Right in the center of the architecture, you have the core language model. That's the engine doing the cognitive processing. But look at what surrounds it. It's wrapped in a loop. The model receives an input, but before it just spits out a final action, it goes up into a monitor phase for self-assessment. It checks its own internal state. Then it loops down into a control phase for self-regulation to decide what to do next. This taxonomy is our roadmap for the rest of the explainer. We're going to break down all these surrounding branches to see exactly how researchers measure, implement, and apply this artificial self-awareness.
Okay, so let's start by unpacking that top left section of the taxonomy. How do researchers even measure if a bunch of code actually has metacognition? I mean, you can't just ask it, right? Well, they're doing it in some really fascinating ways. For instance, they're using psychology-based frameworks like signal detection theory.
They're essentially testing if the AI can separate its own accurate signals from its random, noisy guesses, treating the AI almost like a human subject in a psych lab to see if its confidence ratings actually correlate with getting the right answer. They're even using neurofeedback-based measures. This is wild. They are literally monitoring the internal neural activations of the model while it processes information, essentially doing an AI brain scan to see if it intrinsically knows when it's struggling. Plus, they're building entirely new, specialized tasks and benchmarks just to poke and prod at the model's internal confidence levels. So, what actually happens when we run those measurements today? Well, if we look over at the current findings branch of the research, the hard evidence reveals some pretty stark metacognitive failures. While these large language models definitely show glimmers of self-reflection, they currently suffer from deep systemic overconfidence. For example, they exhibit something called escalating certainty. This means the more they talk, the more convinced they become of their own lies. It's like they talk themselves into believing a hallucination. Even wilder, and frankly a little absurd, is the think-answer mismatch. This is where researchers peek under the hood and see the AI's internal reasoning completely contradicting the final answer it gives you. It literally knows better, but it spits out the wrong thing anyway. And unlike humans, they have a terrible inability to look back and retrospectively adjust their confidence once they've made an error.
Now, what's really interesting here is how we intervene to fix these failures. To understand the fix, we have to contrast how a standard model behaves versus a newer, agentic system. A standard language model is entirely reactive. You give it a prompt, and boom, it instantly spits out the first predicted token, and then the next, flying by the seat of its pants. But engineers are now hacking self-awareness into agentic systems. An AI agent is specifically designed to pause. It reflects on the prompt, it drafts an answer internally, it critiques its own work, realizes it made a mistake, fixes that mistake, and only then does it give you the final answer. It perfectly mimics that human monitor and control loop we talked about earlier.
Moving over to the implementation side of our taxonomy, we can see exactly how researchers are explicitly giving these models these metacognitive abilities. They are actively teaching the AI to doubt itself. Sometimes this is pretty simple, done through prompting frameworks, like explicitly giving the AI instructions to monitor, then generate, then verify. Other times it's way more complex, requiring them to build specialized architectures from the ground up. Take the state stream transformer, for example. It literally hardwires a pause and reflect mechanism directly into the AI's core circuitry. Researchers are also fine-tuning models on self-corrected reasoning traces. Basically, they show the AI thousands of examples of what self-doubt and correction actually look like in practice. They're even using reinforcement learning that rewards the AI not just for being right, but for accurately knowing how confident it should be.
Let's move along and see how this builds, because when we combine these architectures, we unlock dynamic, real-time adaptation. Step 1 is multi-agent debate. You can actually have different AI agents argue with each other, forcing them to self-assess, defend their points, and find flaws in their own logic. It's amazing. Step 2 is knowledge boundary detection. Now this is massive. This is the AI realizing, my training data cut off in 2023, therefore I physically cannot answer this current events question. It recognizes its own limits. And step 3 is self-improvement and strategy selection. This is where the AI realizes its current approach just isn't working and pivots to a new tool, like deciding it needs to search the web or use a calculator instead of just relying on its internal memory.
So, referring back to the outcomes of all this research, we have to emphasize the massive payoff here. Why go through all this trouble to build self-doubt? Because improving metacognition leads directly to fixing the absolute most frustrating flaws in current models. It results in better general task performance across the board. It drives a massive reduction in those stubborn hallucinations we all hate. It creates resistance to persuasion, so a user can't just bully or trick the AI into agreeing with a false statement. It makes the AI's internal reasoning completely transparent to us humans. And finally, it allows the whole system to efficiently and intelligently allocate its computing resources, saving time and money.
So the crucial point to take away from all this is how it actually affects our daily lives. Ultimately, this entire field of research is about human-AI collaboration. As AI integrates deeper and deeper into society, we absolutely need systems that we can implicitly trust. Imagine an AI assisting in a high-stakes medical setting. We do not want a system that guesses a diagnosis with absolute certainty when it's actually confused. We want an AI that safely and humbly defers to human doctors, clearly stating, you know what? I don't know. My evidence is conflicting here. Whether we're talking about reliable AI tutors for our kids or critical decision-making systems in businesses, the ultimate feature of advanced AI isn't knowing everything. It's having the simple humility to admit what it doesn't know.
Which leaves us with a really fascinating paradox to consider. We spend so much time, energy, and billions of dollars trying to make AI smarter, faster, and more confident. But the absolute cutting edge of science right now, it's actually trying to teach these machines the very human art of self-doubt. So I'll leave you with this to ask yourself. When artificial intelligence finally achieves true metacognition, when it finally learns to pause, reflect, and admit its own uncertainty, will that make you trust the machine more or less? It is a question that is absolutely going to define our future relationship with technology. Thanks for joining me on this explainer, and keep questioning everything, especially the things that seem absolutely certain.